The HAL Tejas Mk2 is not just an upgrade. It is India's definitive step into medium-weight, multi-role combat aviation. A jet designed to fill multiple shoes, replacing the IAF's aging MiG-29s, Mirage 2000s, and Jaguars, while meeting the future challenges of electronic warfare, precision engagement, and deep strike operations. Developed by the Aeronautical Development Agency under DRDO and built by Hindustan Aeronautics Limited, the Tejas Mk2 takes everything that was good about the Tejas Mk1 and scales it up significantly. The Tejas Mk2 belongs to the medium-weight fighter MWF category. It sits between the light combat aircraft Mk1A and the upcoming 5th-generation advanced medium combat aircraft Mk2. At first glance, it might seem like a simple stretch of the Tejas Mk1, but under the surface, almost every system has been redesigned, upgraded, or reimagined. Let's start with the physical dimensions. The Mk2 is longer and broader than the Mk1A. Its length has been increased from 13.2 meters to approximately 14.65 meters. The wingspan has been slightly increased to accommodate more weapon stations and better lift. The aircraft's maximum takeoff weight has gone up from 13.5 tons in the Mk1 to 17.5 tons in the Mk2. That's a 4-ton increase, pushing the Tejas Mk2 firmly into medium-weight territory. The airframe uses a higher percentage of composite materials, ensuring strength while keeping weight in check. The design has also been optimized for a lower radar cross-section. Edge alignment, airframe shaping, and internal component placement reduce its signature in radar and infrared spectrums. Though not a stealth aircraft, it incorporates multiple low observability features, making it harder to track and target. Now let's talk about the engine, the heart of any fighter aircraft. The Mk2 ditches the F404 engine used in the Mk1 and Mk1A. Instead, it's powered by the General Electric F414 GAINS 6-turbofan engine. This afterburning engine generates 98 kilonewtons of thrust, nearly 15% more than the F404. The increased power translates to better climb rate, acceleration, top speed, and, crucially, supercruise capability. That means the Tejas Mk2 can sustain supersonic speeds without using afterburners, which is vital for saving fuel and reducing infrared signature. With this power plant, the Mk2 can achieve speeds of Mach 1.8, a service ceiling above 50,000 feet, and a range that exceeds 2,000 kilometers with drop tanks. Internal fuel capacity has been increased by 1.5 tons compared to the Mk1, offering greater loiter time and deeper strike capabilities. Weapons capability has been given a huge upgrade. The Mk2 carries 13 hardpoints, compared to 8 on the Mk1. These include 4 underwing pylons on each wing, 1 centerline pylon, and additional points for electronic pods and refueling probes. This allows the Mk2 to carry up to 6.5 tons of external stores, making it capable of multiple mission profiles in one sortie. Air-to-air capability comes in the form of Indian-made Astra Mk1 and Mk2 beyond visual range missiles, the Israeli Derby and Python 5, and the Russian R-73. It also supports close combat missiles and infrared-guided weapons. For air-to-ground roles, the Mk2 integrates laser-guided bombs, glide bombs, and smart anti-airfield weapons. It is capable of deploying DRDO's Rudram anti-radiation missile for seed suppression of enemy air defense missions, and BrahMos ING, the lighter version of the BrahMos cruise missile, for deep precision strikes. The aircraft is also compatible with nuclear weapons delivery, giving it strategic value. Avionics on the Tejas Mk2 are world-class. The radar is a completely indigenous Uttam AESA radar, developed by DRDO. With over 700 transmit-receive modules, it is capable of tracking more than 50 targets simultaneously, engaging up to 6 of them at once. The radar's range exceeds 200 kilometers for fighter-sized targets, and it can operate in high ECM environments with strong resistance to jamming. The cockpit layout has undergone a major redesign. The traditional multi-function displays have been replaced by a large area display, similar to what is seen in 5th-generation jets like the F-35. The widescreen interface allows pilots to customize layouts, overlay sensor data, and switch modes quickly. It's supported by a hands-on throttle and stick (HOTAS) control system and an indigenous holographic head-up display. The digital fly-by-wire system has been improved further from the Mk2 version, allowing better maneuverability and flight stability. This system is quadruplex redundant, ensuring safety even under combat stress or during high-G maneuvers. Electronic warfare is an integral part of the Tejas Mk2's capability. The aircraft includes a fully integrated indigenous EU suite with radar warning receivers, jamming pods, towed decoys, and countermeasure dispensers. These systems are capable of detecting incoming radar threats, jamming enemy tracking systems, and deploying flares or chaff to evade missile locks. This enables the Tejas Mk2 to survive and operate even in dense anti-aircraft environments. Tejas Mk2 also features infrared search and track (IRST) sensors, passive systems that allow detection of enemy aircraft based on heat signatures without emitting signals that give away the aircraft's location. IRST is especially effective against stealth aircraft, cruise missiles, and low-flying threats. The aircraft supports mid-air refueling through a fixed probe on the front right side. This allows it to work with Indian Air Force tankers like the Il-78 and future MRTT platforms, extending its range and loiter time during long-range missions or combat patrols. Communication and situational awareness have been improved drastically. The aircraft features secure data links, satellite communication capability, and is fully network-centric. It can share and receive data from AWACS, ground stations, and other friendly aircraft, creating a real-time battlefield picture. This is essential for modern air combat, where information superiority often means mission success. Another important point is the open architecture of the Tejas Mk2's mission computer. This means future systems, be it missiles, sensors, or software upgrades, can be integrated without major redesign. It's future-proof by design, built to evolve with changing combat environments and technology. The production plan for the Tejas Mk2 includes at least 10 prototypes, with the first expected to fly soon. Full-scale production is targeted for 2026, with induction into the Indian Air Force likely by 2028. The IAF has already shown interest in procuring at least 120 Mk2 fighters to replace aging fleets, with more possible depending on operational performance and export potential. International interest in the platform is growing. Countries in Southeast Asia, the Middle East, and Latin America are closely watching its development. Its cost-effectiveness, indigenous components, and multi-role flexibility make it attractive for nations seeking to modernize their fleets without depending heavily on Western or Russian platforms. Tejas Mk2 is not just about replacing old aircraft, it's about redefining how India builds and deploys its fighters. It embodies years of research, failures, refinements, and breakthroughs. Every component, from the radar to the EU suite, from flight controls to the cockpit interface, has been designed with future combat in mind. In comparison to competitors, the Tejas Mk2 holds its own. Against the F-16 Block 70, it is lighter but more agile and fully networked. Against the JF-17 Block 3, it offers superior build quality, indigenous systems, and better payload. Against the Gripen E, it matches in terms of radar, engine thrust, and sensors but offers the strategic independence of local production. Its biggest strength, indigenous development. Nearly 70% of its components are made in India, with plans to exceed 80% localization by full-rate production. This means lower dependency on foreign vendors, better control over costs, faster maintenance, and assured support throughout its service life. Tejas Mk2 is also a stepping stone. The lessons learned in its development are already being used for the Mk2, a fifth-generation fighter India is co-developing. Technologies like stealth shaping, advanced composites, and sensor fusion are being matured through the Mk2 program. HAL is preparing a state-of-the-art production line in Nashik and Bengaluru for the Mk2. This includes robotic assembly, automated quality control, and digital twin technology to simulate real-world usage for each aircraft built. These modern production practices will ensure faster delivery timelines and consistent quality, especially for large-scale IAF orders. In future variants, the Tejas Mk2 could be equipped with indigenous engines, further reducing foreign dependence. Talks are already underway for the co-development of a 110 kilonewtons class engine between India's DRDO and international partners. Once complete, the Mk2 could become entirely self-reliant in propulsion. Even in the international defense community, there is recognition that Tejas Mk2 represents more than just another fighter program. It's a national endeavor that combines cutting-edge aerospace engineering, strategic autonomy, and long-term force multiplication. It is a response to both immediate tactical needs and long-term strategic requirements. With the rise of drone swarms, stealthy intrusions, and hypersonic threats, the battlefield of the future demands a fighter that is flexible, fast, and fully connected. The Tejas Mk2 is being shaped to answer that call. India's defense industry has come a long way from assembling kits to building complex fighters at home. The Mk2 is the result of decades of perseverance, talent, and innovation. It's a signal to the world that India no longer needs to rely on imports to defend its skies. The sky may be vast. The threats may be real. But with Tejas Mk2, India flies forward, on its own wings, with its own firepower, for its own future.